Hi, finally we are going to go through the final video on static indeterminacy of frames. Okay, let's start with the first problem. If we look at the first problem, what we can understand is this particular structure is, this particular frame is stable, fine. Why? Because it just stands on one fixed support, so R is equal to 3 is met, and we also know that a fixed support is fine. Okay, so as such, there is no issue with regard to stability. Next, should we use the formula necessarily? No, because we can clearly see that this is an open tree. Okay, when I explained the open tree method, I told clearly that an open tree with all its arms open without having any closed loop is statically determined, and hence there is no need of formula. Directly, we can declare that this is determinate and stable. Fine. Second problem. Here in this case, r equal to 3, m equal to 4, and j equal to 5. Use the formula 3m plus m minus 3j. And then don't forget to include this minus 1 for the presence of entire means located here. So we see that this gives a negative value, that is we will end up getting minus 1, which means this is unstable. Okay, because without this internal hinge, this portal frame will be stable enough. Just because we are introducing this internal hinge, we get one extra, or I can say one equation of condition, which is not necessary. If this is there, then maybe I need to replace this roller support with a pin support to make the number of wickets equal to number of arms. Okay, because of that, this is becoming unstable. Fine. Next problem. This is also straightforward. M equal to 2, R equal to 6, and J equal to 3. Use the formula, you get S equal to 2. Okay, the static inverse in this case is 2. This is the way if you want to use the formula. Otherwise, if you use the method of open tree, allow the open tree to stand on this fixed support, let's say, then second step is remove excessive reactive components. Let's remove these three. Okay, that those are the three that should be removed. And then we need to account for any internal release. Okay, so I have three already. For internal I get minus one, so 3 minus 1, which will also give value of 2. Fine. Right. Fourth one, just because this particular frame is made of inclined members and plane support doesn't mean that we need to be confused. So directly here also we can apply the formula, but rather what I'm going to do is I'm going to use again the method of open tree. Okay. So directly we have a fixed support, allow the tree to stand on this fixed support. Finally, just remove these two reactive components which are in excess. So static indeterminacy is 2 straight away. Fine. And it is stable as well. There is no issue with regard to stability. Then we have this fifth one, which is interesting. Okay, we have a lot of numbers contained in it. You can count the number of members, it will be equal to 21. Number of reactive components equal to 6, because 3 plus 2 plus 1, 6. And the number of joints also you can check, and it will be equal to 70. Use the formula. So with the formula, this is what it is. Just I rewrote it as 3m minus j plus 1. Okay, and then we need to consider the presence of releases. Okay, so for axial release we get a minus 1, because at this location the axial force will be equal to 0. Okay, so this is shear release, and hence what will happen here, let me use n equal to 0 for axial release, for shear release v equal to 0, and at the location of moment release sigma m equal to 0, there are 4 members, so 4 minus 1, which is applicable 3 times. Okay, so the n equal to 0, n is equal to 0 equal to 1, and this location gives one extra condition, and this gives one extra condition. Shear release and finally moment release also gives the extra condition. This also should be accounted for. All right. So finally, when you sum up all this, the static indeterminacy turns out to be 30 in this case. Fine. The same could be done using method of open tree. I'm not going to tell it in detail. Just I will give a brief idea about how it is done. So in this case, let's say the tree will be standing with this fixed support. Okay, by this fixed support I mean. So the next step is to release the reactive components at this location and this location. So that there are totally three such reactive components VA, HA, VQ. So I wrote three here, and then we need to cut across the closed loops. You can see that 1, 2, 3, 4, and then here also 1. Totally 5 loops are there. So I'm just I have just mentioned the numbers, okay, which are to be cut. Okay, for instance, GH. GH means here I need to make a cut, and then I will make a cut, and say here I'm making a cut, here I'm making a cut, and then here. Okay, all such pi cuts should be accounted for to release the internal stress resultants. So this 3 plus 15 gives a value of 18, and then this pi is for the internal releases. So this again gives a value of 13, which matches with how we obtained it using formula. Okay, and then sixth one, this is a little different from what we have discussed so far. So we have this arrangement here, that is a roller is available between these two frames. Okay, so here again I am using the method of open tree. Let's say this tree stands by this fixed support. Then the second step is remove excessive reactive components. So two should be removed here, two should be removed here. Okay, this is considered internal, so we are not going to it directly. Here two, 2 plus 2, 4. Okay, that I wrote here already. What about this here? Here there are two conditions, or I can say equations of condition available. One is what? The original force should be equal to 0 at this location, and the bending moment MC should be equal to 0. Okay, so we have these two equations of condition that should be taken into account. So four reactive components are there in excess, and we have this. Okay, that is equations of condition. So 4 minus 2 is equal to 2. That is the static indeterminacy of this particular frame. And finally, we have this one. This is what this looks like an arch, but this is not an arch. This is a bowstring girder frame. Okay, this is a frame. So in this case, how do we find the static indeterminacy? Same idea. Let's say we have some loops here. You can see 1, 2, 3, 4, 5, 6, 7, 8. Okay. So all these 8 loops should be made open, cut open. So I'm cutting across all these numbers what I am mentioning here. So if when we cut across each of these, three interstress resistance are being released. So 8 into 3, how many? 24. That is internal, we can say. Okay. Externally, if you look carefully, we see that there are two pin supports. Usually for external stability, what we just need is a pin support and a roller support. So here at either of this location, we can consider one extra reactive component is present. So I am accounting for that here. Therefore, 24 plus 1 is equal to 25. That's all. All right. Hope this comprehensive session on static indeterminacy of frames is quite helpful. In a couple of days, we will upload the solutions for all the practice problems we upload in our website. So you can go to our website and get the solutions, and you can make use of that to verify your solution. Fine. That's what we expect from you. Okay. Grow along with us, learn with us, and improve yourself. All right. Thanks a lot. Thank you so much for your passion.